Hey everybody, in this lesson we're going to learn how to interpret the names and structures for some alkanes. Okay, so these are single bonded hydrocarbons. And these things can branch and have attachments onto them, and so the naming system for these is a little bit more complicated than some of the other things that we've looked at. But the gist here is that you're going to look at these molecules as a longest chain that has maybe some attachments onto that. And so you're going to need some information about how big is that longest chain. You're going to need some information about what is attached to that longest chain and where it is attached. So a kind of a location. And so the first thing that you want to do is to identify the longest chain that's in a hydrocarbon. And keep in mind that chains can branch. Okay, so for example, in this one here, the longest chain would have to start with this carbon over here and might swirl down here and over here and then up here, and you could either go this way or this way. It wouldn't really matter, but in this one, at 1, 2, 3, 4, 5, 6, 7, 8 is the longest continuous chain of carbons I can find. If I were to go straight across here on the bottom, 1, 2, 3, 4, 5, 6, that's not as long as the chain of 8. So that would be one correct solution to find the longest way. And there may be more than one as long as it matches up with the longest chain. Here, if I started and went straight across, 1, 2, 3, 4, 5, 6, 7, I could do that, or 1, 2, 3, 4, 5, 6, 7. That's another solution. Looks like 7 is going to be the longest continuous connection of carbons I can make there. And there may be multiple different ways that you can do that, but whatever way you choose, it's got to be the longest continuous connection of carbons, or at least a tie for the longest continuous connection of carbons. And once you find that longest chain, you want to name that longest chain. Here, our longest continuous connection of carbons was 8 carbons long, and an 8-carbon alkane is called octane. Here, our longest continuous connection of carbons was 7 carbons long, and so we might call that heptane. Now, that's not the end of the name, because we've got some other things that are attached to it. Okay, so now let's talk about what we need to do about attachments. You want to kind of circle your attachments or highlight them or do it something to anything that's not part of that longest chain, and you want to number the chain so that your attached groups or your substituents are at a lower number. So you might look at your chain and decide, hey, are my attachments closer to this end or closer to this end? Whichever end they're closer to, that's the end that you want to make end number 1. Okay, let's show you that here. All right, so if I were numbering this chain, looks like a couple of my attachments. I've got an attachment here and an attachment here and another attachment here, but looks like most of the attachments are closer to this end than to this end of my chain. And so I'm going to number my chain this way. This is going to be carbon number 1, 2, 3, 4, 5, 6, 7, and 8. Okay? All right, so, and you want to name your attachments as well. So a 1-carbon attachment is called a methyl attachment. I have another methyl attachment here and an ethyl attachment here. Okay, so we're identifying what kind of attachments those are. The kinds of attachments, if they are carbon attachments, basically you're going to change your ane ending that would have been on a hydrocarbon, like methane for 1 carbon, ethane for 2 carbons, and just change that ane ending to an il ending for however many carbons big your attachment is. And so if I have a attachment that's 2 carbons big, then 2-carbon hydrocarbon would be called ethane. We're going to change that to an ethyl attachment, just like an old lady, ethyl. Okay. Now you can also have halogen attachments. If you have group 17 element attachments, we stick a little O ending on the end of those elements. So fluorine becomes fluoro, chlorine becomes chloro, so on and so forth there. Okay. All right, back to this guy. So here I've got these methyl attachments and an ethyl group. Before I finish the name for this one, I want to do one that's a little bit simpler. Okay. All right, so numbering the parent chain. Again, it's really important that when you number your chain, you number the chain so that whatever attachment that you have on that chain is at a lower end. And so I could start numbering from 1 over here or start numbering from 1 over here. But it looks like this is going to be better. I'm going to number this chain 1, 2, 3, 4, 5. If this attachment had been closer to this end, I might have made this carbon number 1 instead. Okay? So that's important because it's going to tell me this attachment is attached at carbon number 2. That's the purpose of numbering that chain, so that you know where the attachment is attached. The longest chain here is called pentane. And I have an attachment at the 2nd carbon. On that 2nd carbon, I have a methyl attachment. And since that attachment is attached to the 2nd carbon, the name of this molecule is going to be 2-methyl-pentane. Basically, this tells me where the attachment is. This tells me what kind of attachment do I have. And this tells me the parent chain. What is that attachment or that substituent attached to? Now, you can have multiple attachments, like we saw in this more complicated example back here. If you have multiple attachments, then there is a way to deal with that. They typically go in alphabetical order, so your ethyl might go before your methyls. And if you have more than one attachment of the same type, then those can have prefixes that tell you how many of those attachments you have. In other words, these names are already so long, I would not want to say the word methyl twice here, even though there are 2 methyl attachments. And so I could take care of both of those by putting a prefix in front of methyl that tells me there's 2. Prefix for 2 is di. And so I could say that I have a dimethyl. Now, I would also need numbers to say where those things are. Okay? All right, so all together, just to kind of give you an example here, the name of this compound would be 5-ethyl 2, 3 dimethyl octane. Now I want to focus on just kind of this portion here for a second. Notice we've got 2 methyls, one's attached at 2 and one's attached at 3. And if you have that kind of scenario, and you can do this with 2 attachments of the same kind or 6 attachments of the same kind, it doesn't matter. Just put the addresses, the locations, the numbers for where those attachments are attached all up front with commas between them, and then have a prefix that says how many of that same kind of attachment you have. So 2,3-dimethyl tells me I have 2 methyls attached at numbers 2 and 3 on a larger chain of octane. Now, when you're alphabetizing to put them in order, you would want to be comparing the M in methyl to the E in ethyl alphabetically. So E comes before M in the alphabet, so ethyl comes before methyl. Don't worry about whatever don't worry about alphabetizing the D in di. You don't need to do that. Okay. Here's kind of a summary of what we just did. Okay, so if you are here, we'll do maybe a couple more here. All right, so here's an example, maybe from a line angle formula. What if I had this molecule? Okay, don't want to get too crazy. All right, that's pretty good. All right, so again, you want to try to find the longest chain first, the longest continuous connected chain of carbons. And looks like, I'm going to have to probably bend down here to get the longest chain. And it's probably going to go all the way over to the end here. All right, so there's my longest chain. Then you would want to identify your attachments. So it looks like here I have a methyl attachment. This is 1 carbon big. Here I also have a methyl. And here I have a 3rd methyl. So 3 methyls, and they're all attached to a chain. That looks like most of my attachments are closer to this end, so I'm going to start numbering from this end. 1, 2, 3, 4, 5, 6, 7. Looks like the big chain is a heptane. So then I would want numbers to say where those methyls are. I have one at 3, I have one at 4, and I have one at 5. This would be a 3, 4, 5. If I've got 3 methyls, I don't want to say methyl, methyl, methyl. I want to say trimethyl. And then heptane. So 3, 4, 5 trimethyl heptane. Okay? So that shows multiple attachments of the same kind. We showed one here where you had different kinds of attachments and you had to alphabetize the ethyl before the methyl. Notice that the numbers were put directly in front of each kind of attachment to say this is a location for the ethyl and this is a location for the methyls. What if we're going back the other way? All right, so here, if we want to interpret the names a little bit differently, if you need to build a structure, you want to go in reverse. You don't want to put on the roof and the windows and all that kind of stuff before you build the foundation. So you probably want to start with the end of the name and figure out what the longest chain is, and then build that longest chain. Now, if you're doing line angle formulas, keep in mind your first carbon is going to be as soon as your pen touches paper. So this will be carbon number 1, and then carbon 2, 3, 4, 5, and 6. Okay? So that's the hexane part of the compound. Then if I want to show this attachment, well, it's an ethyl attachment, which means it's a 2 carbon big attachment. And that number 3 tells me where on the chain it is. And it doesn't matter which end you number from, but typically I number from left to right. So if this is 1, 2, and this is 3, I'd have to have an ethyl, which would be a 2 carbon large attachment. That means it would have to have a bend in it. So this would be the first carbon off the chain, and this would be the second carbon off the chain. If you wanted to turn this into a condensed structural formula, just keep in mind that every carbon's got to have 4 bonds. So if this carbon on the end here is only connected to one other carbon, then it's going to have room for 3 hydrogens. That's carbon number 1. Carbon number 2 is going to have room for 2 hydrogens because it's already connected to 2 carbons, so it's got 2 spots left over. Carbon number 3 here is already connected to 3 other carbons, and so it's only going to have room for 1 hydrogen. Carbon number 4 here is going to have room for 2. Same with carbon number 5. And carbon number 6 is on the end, so it's going to have room for 3 hydrogens. Basically, I'm just looking at how many bonds are coming out of that 1 carbon on the line angle formula and then subtracting from 4 to have the hydrogens as the leftover spots that are not connected to carbons. Now for the attachment, I could come down here and say, okay, this is CH2 attached to CH3. All right? Let's do another one. Get a little faster this time. I've got a 2,3-dimethyl butane. Butane means it's 4 carbons big. I have 2 methyls at carbons 2 and at carbon 3. There's 2,3-dimethyl butane. This would be CH3 attached to CH, attached to CH, attached to CH3, because those middle carbons only have room for 1 hydrogen. And the attachments are on the end, so they have room for 3 hydrogens. CH3. Okay? All right, that's all we have time for this time. Until next time.